up on the other side about 1948.
We're now about 18 minutes away from release of the Spartan platform as Ochoa continues moving the arm and platform into the position for release, centered above cargo bay of Discovery. The payload deployment retrieval systems officer reports he sees Ochoa making final adjustments to the release position as she wraps up work with the arm to move it into position.
This is Mission Control Houston. The Spartan satellite was deployed on time at about a little after 1 o'clock this morning over portions of Northeast Africa and Egypt area. Shortly after the deploy, the orbiter Discovery conducted a very soft 0.9 foot per second separation maneuver to slowly separate from the satellite, and shortly after that the satellite began a pointing maneuver on its own called a pirouette to position itself for its science data takes.
this wider view of the cargo bay, also showing the Atlas payload, the instruments making up the Atlas II payload mounted on the Spacelab pallet. Closer look here at the aft bulkhead area of the cargo bay with the millimeter wave atmospheric sounder dish antenna, portion of it anyway visible in the lower portion left-hand side of the screen.
One of the cameras did catch what appears to be a little bit of multi-layer insulation that's separated from the aft bulkhead, and the environmental and consumables officer reported that they were taping that, but it didn't look like it was going to pose any problem, as it looked like it had only separated just a little bit. But he is going to take a look at that, and some of the other flight controllers will take a look at what, if any, systems of theirs are behind that bulkhead of the aft portion of the orbiter. Any concern would only be related to thermal or temperature variations that might heat up or cool down the aft bulkhead because of the slight separation of that multi-layer insulation on the aft bulkhead of the orbiter. The robot arm that's used during deploy and retrieve operations on this mission, particularly with the Spartan satellite, is currently in what's called an extended park position out over the nose of the Space Shuttle Orbiter Discovery. This position allows for enough clearance for all of the science instruments that are located in the payload bay of the orbiter.
This is Spacelab Operations Control, Huntsville. We continue to receive live downlink video from the payload bay of Discovery showing the shuttle solar backscatter ultraviolet experiment. Meanwhile, standing by for an update on science activities in the Atlas II area from Atlas II mission scientist Dr. Tim Miller, who will be briefing the crew aboard Discovery in a minute or two about activities that have been going on over the past 24 hours since its last update.
come on in, Carl, and we're looking at the IMU angles, and we think we're ready to torque.
You're ready to torque. We like
This
them
is
also,
Mission
and we're
Control,
coming into the
Houston.
cabin.
Roger, and Mike just wanted me to say that he's still setting things up.
Okay.
This is Mission Control Houston, now taking some live downlink television from the aft flight deck of Discovery, looking at Mission Specialist Mike Foale.
Okay, my name's Michael Foale. I'm a mission specialist on board the Space Shuttle Discovery. We're here in orbit today, taking part in part of the Atlas II series of payload experiments. And I want to tell you about one of them. It's the Atmospheric Trace Molecule Spectrometer, or ATMOS experiment. ATMOS is a special instrument that's able to measure molecules in our atmosphere to about 1 part in 1 trillion. We launched into space a few days ago. We lifted off from Cape Canaveral and flew north up the east coast so that we would encounter sunrises. And you can see there's a lot of sun up here. It's very, very bright when the sun's up. We encounter sunrises in the northern latitudes, around about 60 degrees north. As it dries up over the 60-degree north latitude line, ATMOS looks out over the side of the Space Shuttle's wing towards the sunrise. And as the sun comes up above the surface of the Earth, its light comes through the atmosphere and grazes the top of the atmosphere. And we see the atmosphere about as thick as our thumb looking out the window. So anyway, these light rays from the sun pass through the atmosphere, and some of the different colors get absorbed so that ATMOS can look at the different colors that have been absorbed, and because certain molecules absorb light differently, ATMOS is able to tell what molecules are actually present in our atmosphere.